Hi everyone, my name is LPAR CHPID. Welcome to my YouTube channel Amazing LPAR. Imagine a large apartment building where every apartment has its own locked door, its own living space, and its own allocated utilities. The residents share the same physical building, but one resident cannot simply walk into another apartment and use its belongings. An LPAR works with a similar idea. It creates an isolated logical computer inside one physical machine. Each operating system runs inside one of these partitions and receives its own compute and I/O resources. This topic is important because nearly every configuration decision we make later is really about giving the correct resources to the correct LPAR. The easiest mental model is to stop thinking of an LPAR as a folder or a software process. Treat it as a virtual computer. From the operating system point of view, it receives processors, memory, and I/O resources and behaves as though those resources belong to its own machine. The isolation is a major part of the design. An operating system in one partition cannot simply look into another partition's memory or take over another partition's paths. Sharing only happens when it is deliberately configured. This is why the apartment analogy works so well. The physical building is shared, but the boundaries between apartments are real and enforced. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing LPAR grow naturally. A partition is defined by two different sets of information that work together. Think of opening a new office. One document tells you how much floor space, electricity, and staff capacity the office receives. Another tells you which network connections, storage systems, and shared services the office is allowed to use. For an LPAR, the activation profile defines the compute side such as processors and memory. The I/O CDS defines the I/O side such as channel paths and devices. If you only understand one half, you do not have the full picture of the partition. The human readable name also matters, along with the CSS number and MIF identity used by the machine. Engineers coming from smaller systems sometimes look for a physical object that corresponds to a partition. There is no card labeled LPAR 3 and no drawer that belongs only to a specific partition. The partition is logical, but its effect is very real because the hardware firmware enforces its boundaries. Physical processors and memory are mapped to logical partitions by the platform. On the I/O side, CHPID are the physical port addresses. This logical to physical separation is what gives the machine flexibility. Workloads can receive logical resources without every partition needing a dedicated set of physical components. Before we move ahead, please take a second to share on this video. Sharing helps this video reach friends who may also enjoy anime, gaming, travel, cricket, chess, career basics, or personal stories. Your support helps Amazing LPAR grow naturally. This is where the apartment building comparison becomes most useful. Production and test can live on the same physical machine while still being separated. The production partition receives its own memory and approved I/O paths. The test partition receives a different set. One partition does not get to cross the boundary just because the underlying hardware is shared. If sharing is required, it must be designed deliberately. This isolation is one of the reasons many workloads can coexist on the platform with clear control over access. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing LPAR grow naturally. The source material gives a useful architectural maximum. A large machine can support up to 6 channel subsystems, and each CSS can contain up to 14 LPAR. 6 groups of 14 gives a theoretical total of 84 partitions. Think of it as 6 floors in a building with 14 apartments on each floor. The exact number available depends on the machine model, so the model-specific limits still need to be checked. The point of this slide is not that every system has 84 partitions. The point is that the architecture was designed to scale to many independent operating system images on one physical machine. The simplest way to remember an LPAR is this. It is a virtual computer with real isolation. The operating system sees processors, memory, channel paths, and devices that belong to its logical environment. The compute definition and I/O definition work together. The partition itself has no single physical card or slot. Instead, the hardware maps shared physical resources into isolated logical environments. With that picture clear, the next question is how the machine identifies each of these many partitions precisely. That leads directly to MAF and the MAF ID. If you enjoyed this video, please hit the like button and subscribe to Amazing LPAR. Subscribing makes sure you do not miss the next video, and it gives me motivation to keep improving the quality of every upload. Thank you for being here, and I will see you in the next one.